Hi, everyone. This is Bruce B. Wald, CEO of Synapse Energy Economics. Welcome to our third Thursday webinar. This month, we're going to be talking about climate damages and uncertainty with a kind of focus for examples from Florida. So let me start with so seriously, welcome. Glad you're all here. Let me start with the logistics. This webinar is recorded, so it will be circulated, available afterward. Everyone on the line here is muted. We're planning to keep you muted, but you can send questions and comments, I suppose, to a webinar at synapse-energy.com. So if you send questions, we will field them while you're, for the next hour. So send them along, and we'll collect questions and pose them to Frank, our presenter for today. There's also a chat feature, but we'd rather if you just use that for technical things and use the email for your substantive questions. I wanted to give you a heads up that next in a couple of weeks, specifically Thursday, May 9th at 2, we'll have a follow-up webinar. We're planning to have Debbie Glick from Synapse and Kevin Lucas, Director of Rate Design with Solar Energy Industries Association, talk about their work in Florida. It kind of follows, it's highly related to the topic that we're talking about today, as you will see. Next slide. So our topic around climate damages, climate economics, and uncertainty is something we've been working on for ages, decades, several decades really. But most recently, we did a report for the Sierra Club related to the Big Bend plant proposed by Tampa Electric. So it's a big investment in the gas generating capacity in the Tampa area, and in particular, Frank and I worked on a report that we were prepared to present, but then it turned out that the judge in the Big Bend hearing decided that it wasn't admissible. Basically, they didn't want to hear from us on climate damages or from other witnesses like Debbie and Kevin on grounds that we'll probably talk more about next time. So for today, we're lucky to have Frank Ackerman with us, and he is going to talk about climate damages, the social cost of carbon, basically economics of climate change, and again with examples from, but not limited to Florida specific situation. So Frank, you are on the line, yes?
Yes, I am. Thanks.
So why don't you take it from here?
Yes. So I'm going to talk about the economics of climate policy, and as Bruce said, Florida is a perfect example. The problem that we face is that climate change looks different in science than in economics. Scientists often see it as a fundamental threat to our future. More and more evidence that we've got to do something quickly. Economists tend to see a second-order policy problem. Let's not spend too much. Let's not price carbon too high. The problem is they're both talking about the same issue, and one of them has to be wrong. They can't both, be right about the evaluation of it. We have had these incredible efforts to find something wrong with climate science. We've had just, one after another critique. Are the scientists conspiring to exaggerate this? Nothing has come of that. Typographical errors, stolen emails. Nothing has disproved anything about the climate science, which makes me think we need a new climate economics, which is somehow tells an economic story consistent with the urgency that comes from climate science. Why Florida? well, inspired by it's the economy, stupid, it's the geography. Florida is sticking out there right into the path of where hurricanes happen. Clearly the hardest hit of the 48 states. Alaska, Hawaii present very different issues, but you get a lot of hurricanes, you get a lot of exposure to sea level rise, the potential storm surge areas. You can see the coasts, and there's an enormous amount of property at risk from even moderate sea level rises. There's enormous opportunity for change because it's a very sunny, it's the sunshine state, but has made almost no use of the solar resource that's there. That's Debbie will be talking more about that next time. But standard approaches to policy begin with the need for a number. Economic policy is increasingly based on cost-benefit analysis, and cost-benefit analysis requires that you put a price tag, a monetary valuation on everything that matters. The picture here is just a goofy illustration of how illogical it seems to try to put the same numbers on completely disparate impacts. How bad will climate damages be? Well, once you put prices on them, you can come up with a numerical answer. Again, the science says we're not certain exactly, but we know the worst case risks look pretty bad. The economic approach has been to calculate what's been called the social cost of carbon, the present value of the damages caused by a ton of CO2. And the Obama administration, which took this approach seriously, their working group came up with a price that converted to today's dollars about $51 per ton of CO2. So it's either uncertain but ominous or $51. I want to suggest that a different policy framework makes much more sense. Don't think about cost-benefit analysis, think about buying insurance. So why does anyone have insurance? The average US housing unit has a fire every 360 years. That is to say, number of fires reported to fire departments divided by number of housing units. It's 1 over 360. That gives us a 0.3% probability that you or anyone else you know will have a fire next year. And yet I believe that almost all homeowners have fire insurance, even if they're not required to by their mortgage. Something very similar for life insurance for young parents. The annual probability of death is under 1% until 60. It's under 0.2% until you're 40. A lot of young parents buy life insurance. Why not cancel it? Spend the premium on something else that you'll enjoy. Your standard of living clearly goes up in any year when you don't have a fire or die that year. Suppose we think about catastrophic climate change in the same framework. We don't know the timing exactly, just like we don't know the timing of residential fires, but we know that the tipping points at which catastrophic change happens get less unlikely every year as the world warms, raising the question, should we buy insurance for the planet, as a different way of thinking about climate policy. Insurance never passes a cost-benefit test in simple terms. The insurance company's profit is its customers' losses. That's what they're doing. They're selling insurance policies. If they make money, you in the aggregate are losing money. If it was not the case that the customers were losing money, the insurance company would be bankrupt. Why does anybody do this? Insurance customers are paying to reduce catastrophic risk, which they could not afford to cover themselves, even if on average they lose money. Now, there are limits to the insurance analogy. People quickly realize, particularly there is no galactic insurance agency. No one's going to offer us a loaner planet to use while ours is towed back to the shop for repairs. So we are talking essentially about global self-insurance, spending money on climate-proofing the planet, figuring out what we can do to reduce emissions, to make the world more resilient, to mitigate the catastrophic risk, and to adapt to the damages that we can no longer avoid because warming has gone as far as it has. It clearly has to be negotiated on a global level to be effective. The social cost of carbon calculation is done by the Obama administration, which is the most used version of this, takes 3 models and averages their results. Dice and Page are very simple, transparent, highly aggregated models, very simple pictures of damages. The fund model offers much more disaggregated detail, but a very idiosyncratic treatment of some of the important categories I'll come to in a minute. If you're interested in this, the National Academy of Sciences produced a definitive book-length critique of this whole process. Proposals for better modeling came out the week before Trump's inauguration and got essentially no press. But catastrophic risk is barely visible in these. It has a limited treatment in Page. They model mid-sized catastrophes, nothing whatsoever in Dice or Fund. So these are not the best models of the economy, not the best models of climate change or its interaction. They're the best known models. And cynical moments, I think they're famous for being famous. They're the perhaps the Kardashians of climate economics. DICE has a role for its transparency and simplicity, not for its detail. And in terms of, does more detail always help? The fund model, this is not actually a picture of the fund model, but it's evocative. The fund model estimates 15 different categories, and several of those have subcategories with separate estimates, so huge effort at estimating separate categories. You have to look closely at it to see that 12 of the 15 categories are always near zero, so that a lot of the detail is not particularly helpful. Huge net benefits in agriculture are included based on clearly dated information. And the problem is that this level of detail can distract attention from a model, which is really always giving us the same answer. So if we want to know how bad will climate change get, how fast will it get worse? Most models, most economists assume that climate damages are a function of temperature and, in some cases now, sea level rise as a separate variable. But the question is, what's the shape of that function? How do we extrapolate from what we know about low temperature impacts to much higher ones? Well, the DICE model relatively arbitrarily assumed there was a quadratic function. It's going to somehow depend on the square of temperature increase. Page was set up to roughly match DICE, so slightly different forms, but it's the same story. Fund has these 15 individual categories. The total estimate they produce is usually lower than DICE. So these are essentially arbitrary assumptions about what will happen to climate damages as temperatures go up. Other researchers, myself included, have modified some of these assumptions, found that if you put very slightly different inputs in, different shape of the damage function, different estimate for high temperature losses, you get different, typically much higher values for the social cost of carbon. One single fact, which has been widely used in this discussion, is that there's a physiological limit to what people will survive, around 10 to 12 degrees Celsius of warming, that without access to air conditioning, death from heat stroke is relatively likely on the hottest day of the year at that level of warming. So if you assume that that's a cutoff, that the economy is essentially destroyed by 10 to 12 degrees of warming, you get a much steeper damage function, a much more ominous social cost of carbon, much higher than the usual estimates. So, so far, I think we've got a huge range of uncertainty. Scientists are not offering precise dates and numbers soon enough to make it precise, but a serious risk of damages many times larger than the usual estimates. And whether or not this is the most likely thing, the highest estimates are too likely to ignore, and they're getting more likely. So we are back to needing that insurance type calculation, saying what is the credible worst case that we should be insuring against? What is the worst that we could see? This is an experiment we're going to do once. What does 21st century climate change look like? So what's the worst case we need to worry about given this uncertainty? Pause for a moment about real versus fake uncertainty. What I've been talking about so far are scientific reasons for uncertainty about how bad climate change will get and how soon it will get that bad. I've talked about that in my latest book, Worst Case Economics. Lots of people have talked about that. There's no relationship of this uncertainty to the fake uncertainty peddled by climate deniers. In terms of this cartoon, I don't know that Marco Rubio ever said that, but that feeling of the flat earthers that the Trump administration is unfortunately now promoting, the idea that we might have to talk about this, take it seriously. Again, this rigorous to hostile vetting of climate science, which seems to happen every few years, finds only typographical errors. Unfortunately, we can reject with some confidence the hopeful scenario that we might get away with no climate damages, but beyond that, it's hard to be precise. Where does that take us for choosing a policy? Well, I think that it's clear that rather than the cost-benefit calculations, we need the insurance or the credible worst-case paradigm. In the worst case that we need to worry about, how much damage is being done per ton of CO2, what's the worst value that we might have to take seriously for the social cost of carbon. That number is at least in the hundreds of dollars per ton of CO2 emissions and possibly growing worse over time. New research keeps finding new climate risks. The higher the CO2 concentration already is, the more damaging it is to add more to the atmosphere. So there are reasons why this number is not only potentially very high, but going up. So back to the self-insurance decision that we talked about, which of the emission reduction strategies that people are talking about cost less per ton than worst-case damages? Here we have the cost of emission reduction, which are relatively well known and dropping very rapidly. Solar power, wind power, even battery storage now are just plummeting downward in price, making these alternatives a bargain. You'll hear more about this in the follow-up talk. So does every feasible emission reduction cost less than some high amount, let's say $500 per ton of CO2? I believe that studies suggest that. I haven't really done the research to fully nail it down, but I believe you could say that practically anything that you could do that's technologically feasible to reduce CO2 emissions could be done for less than $500 a ton. Is it possible that the worst case damages we need to worry about exceed $500 a ton? Absolutely yes. So the story in a way is simple. It says do everything that's technically feasible as soon as possible. It's all cheaper than the worst case damages that we might easily face if we don't do it. So at an abstract level, I think that's the way to think about climate policy. In terms of some Florida examples, there's...
Frank, before we get into that, you kind of touched on the three models.
Yeah.
But could you kind of take a step back and with regard to the integrated assessment models,
Sure.
and talk a little bit, what are the key inputs and assumptions for those models, and then how are they
Sure.
used?
Sure. So there's a astonishing level of hubris, I would say, in these models, that they try to represent the growth of the world economy, the evolution of the environment, the growth of the economy produces carbon emissions, which produce warming, which worsens the economy, so that they try to model the interaction between environment and economy. What's the whole flow of CO2 and other greenhouse gases? The DICE model, the epitome of this simplicity, tries to do the whole thing with 19 equations. So the evolution of the world economy over centuries, the evolution of the climate, and the exact manner in which they interact, all in 19 equations. So it's an extraordinary simplification of a complicated reality, which is done, to try to cut through this, to try to come up with the number that you need for cost-benefit analysis. The picture here sort of cynically compares it to the Delphic Oracle pronouncements. You get these predictions which are hard to evaluate because they come from such extraordinarily streamlining. But this has become semi-standard for economists. Again, if we backtrack another level here, we need a number, right? How bad is climate change going to be? How expensive are climate damages in a cost-benefit framework? If the damages per ton of CO2 really were $51, then if you can reduce emissions for $40, it's a bargain. If you can reduce emissions for $60, it's not. So that number tells you how far up the curve to go, how many things you should be abating, and that's where the structure of these models contains an answer to that question. The way they model the environment affecting the economy tells you how great these damages will be. And wait a minute, let's get forward here.
So you're suggesting that they're both overly grand and ambitious on the one hand and kind of overly simplified on the other.
Exactly.
And therefore useful in limited ways for understanding the problem, but we shouldn't put too much faith in these particular models or this way of looking at it for a point estimate.
No, I think that's
that fair?
Exactly right. Yeah, that the DICE model particularly has this skeletal simplicity that has sometimes been useful, and you can almost see your way through the model, see what's going on. But this question of what did the model assume about how fast the climate gets worse and how fast the economy gets worse as the climate gets worse. Hidden inside that model is a strong assumption about, if you like this sort of damage function business, what's the shape of the damage function? What do you assume about what does a temperature increase mean for damages? If you double temperature increase, will you quadruple the damage as a result? There's really no way to know that. And these strong assumptions hidden in the models about this determine what the numbers are. And I believe, yes, they are too grandiose and too simple at the same time. and that they have locked into a much too low a number. Arguments about relatively low number adjustments in the social cost of carbon.
Okay, thanks, Frank. I think we're ready to move on to dive into Florida.
Dive into Florida. So, a lot of people go to Florida for the beaches. It's a nice picture of people rapidly leaving a beach here. Tourism really is the state's leading industry. Some estimates say it's 10% of GDP, 17% of employment. So the story about climate damage is pretty immediate here. Storm surges, well, it's no fun being out in a storm. They erode the beaches. There's less sand there afterwards. The temperatures are already warm enough in Florida, making it uncomfortably hotter will not increase anybody's interest in going there. And protecting beaches, rebuilding beaches, adapting to storm damages to tourism is very expensive. So that, you know, if I was running the Florida economy, that would be top of my list to worry about. There are other things going on. There's human health impacts. Florida could have a whole lot more very hot days by the middle of the century, and that this would lead to, as near as we can tell, thousands more deaths per year directly related to heat. One of the categories of this is that tropical diseases generally have a temperature threshold below which they can't be transmitted. And dengue fever is a nasty disease that's come from some of the Caribbean islands where it's hotter. Florida has only a few days a year right now that are hot enough for transmission of dengue fever within Florida. But a little bit warmer, you're past that threshold, and you're going to see tropical diseases spreading a lot more. So not only because it's one of the most exposed to sea level rise, but because it's one of the hottest states, getting hotter will make that worse. There's a story about the ecological health, the danger to a lot of the native species, the roseate spoonbill, I forget what the name of the other one is there, but the Everglades has been a spectacular reservoir for wildlife, for species that don't exist anywhere else. They're facing invasive species, Burmese pythons, and things that are, you know, breaking in, eating the native wildlife. The the destruction of the Everglades, which has been very slowly and overcome. You know, they're very expensive long-term plans for fixing the Everglades. Meanwhile, the temperature changes and invasive species are threatening to undo a lot of what was attractive about that. And in addition to people coming to see the beaches, there's quite a population that comes to see the Everglades, the wildlife, and so on, which is another example of what's going to be lost. But the strangest and I don't know if it's the stupidest, there's a lot of competition, but a candidate for the stupidest thing being done is to respond to Florida's growth, respond to the economy is booming, people are still moving to Florida, energy needs are increasing, higher temperatures definitely means more air conditioning. So the state's private utilities are proposing huge expansion of their gas-burning power plants, often right at the waterfront. It's easy to find pictures of property that's right at the waterfront, expensive condos built right up to the seawall and so on. These are two of the latest plants, both ones that we've been involved in with the Sierra Club. One is Florida Power and Light at Fort Lauderdale, Dania Beach, and the other is the Big Bend plant for Tampa Electric Company that Bruce mentioned earlier. Nice pictures of them. They're not small. They're very big plants. They're right on the water, exposed to risks from sea level rise. And if they are built, if the state approves building them, there'll be an enormous issue of sunk costs. The utilities will want to recover those costs over decades. Running the plants, once the plant is built, there'll be pressure to run it. You'll be emitting greenhouse gases at a very high rate through the middle of the century or later. Meanwhile, long before the natural lifetime of these plants, you're going to find that the waterfront location was a mistake, that it saves money in the short run. You've got the infrastructure there. Both of these proposals are rebuilding old plants. It looks like the fast way to get it set up and going, but between sea level rise, storm surges, pressure to cover emissions, this will turn out to be a very expensive choice over the lifetime of the plants. So, and again, you hear a lot more about that one on the follow-up talk to this one. So I can talk more, but I did a recent series of blogs about climate policy. You can link to there. I have an in-depth discussion of some of these issues in my book, Worst Case Economics. And you can click on the Synapse website or my personal website to find out way, way more than you want to know about these things.
So Frank, one question that came up is related to clean energy, solar, wind, storage, and it's the topic for the May 9 discussion. But can you say anything today about the kind of the resource alternatives and what, rather than building gas plants on the water's edge, like in your last slide?
Sure.
Are there alternatives, and how would you go about comparing?
There absolutely are alternatives. Energy efficiency is often the lowest cost alternative. Seems like the state could do a lot more on efficiency. Florida's very sunny. It's the Sunshine State. It's way behind a lot of other states, even like North Carolina. Other southern states have done much better, and particularly states in other parts of the country have done better in building solar power. So as that gets cheaper, solar power is getting cheaper faster. Gas plants are not particularly. So there's tremendous opportunity and apparently growing opportunity to replace fossil fuel plants with renewables. The declining cost of storage is good news because the sun only shines at certain times of day. But with cheap enough batteries, you can save the solar energy for use into the evening. The case, I think, is overwhelming for there being good alternatives.
So thanks, Frank. I think we'll wrap it up here, and I just want to thank everyone for participating, and especially Frank for talking about these issues with us. And I remind everyone on May 16th, the third Thursday, we'll have a webinar on energy subsidies at 2, and the week before that, May 9th, the second Thursday at 2, we'll follow up with more of the what can be done to deal with these problems and costs and risks that Frank has been talking about today. So thank you, everyone. Please join us in the future.